Welcome friends, welcome to a new video of AWS AI Practitioner series. Before going into deep dive session on SageMaker, so these are the very common things and applies to all the LLMs we have. So which are training time hyperparameters. So when training a machine learning models, hyperparameters actually control how the model learns. So these are not learned from data. We used to set them before training. So, and this will be tested in the exam for sure. So which are the main hyperparameters? That is, one is learning rate, batch size, epochs, and regularization and optimizer. So let's learn. What is learning rate? Learning rate is step size for updating the model weights. So that means whenever you will have a high learning rate, that means it will be fast, but obviously there will be an overshooting risk. And if the learning rate is low, that means it will be slower, but it will be more precise. So the step size, if you want to see in any questions also in the exam or in actual implementation, if you want to uh, do update the step size of your model, that what will be the size of the entire model, then you should modify the learning rate of the LLM. Another is batch size, the number of samples processed per update. In one update, how many samples will be processed? If the batch size is small, obviously your model will be stable, but it will be slower. And whereas if the batch size is large, it will be faster, but it will be less stable. So all has pros and cons, and it depends on your business context. So based on that, we will modify the hyperparameters. Another is very important hyperparameter, that is epochs. Epochs is full passes through the training data set. So number of epochs means how many times it has passed to your full training data set. If the epochs is too few, means it's underfitting. I will explain underfitting and overfitting in my next slide. So if the epoch is too few, means it has passed through very less times through the entire training data set. So that is underfitting. And if it is too many times, if the epoch is passed, that is overfitting. What is regularization? That is also an hyperparameter. It is actually a technique by which we can prevent overfitting. So, and main point to remember in regularization, that it adds penalty for complexity. More regularization, it becomes simpler model. So, and what is optimizer? Algorithm for updating weights. Example SGD, so or Adam. And main point is it affects speed and stability of the training. So for exam, you need to remember, so if you need to prevent overfitting, we need to use more training data, not the test data, and apply regularization. So let's learn what is overfitting, underfitting. I'm using these terms, but for this slide, try to remember at least these hyperparameters: learning rate, batch size, and epochs. So now, uh, first, before going to overfitting and underfitting, we need to understand three different concepts, and it is also common to all the LLMs, not only in AWS. What is bias, variance, and hallucination? Bias is actually error from simplifying assumption in your model. So, bias means, suppose it has flawed data or assumptions leading to unfair or inaccurate predictions. Means your model is too simple, it miss patterns. That means it's actually underfitting. That is the effect of bias. Whereas variance is error from too much sensitivity to training data. Means it reflects the sensitivity to training data, and model memorizes the patterns instead of learning general rules. It is actually trying, variance is, it is trying to learning or memorizing the patterns you have given. So instead of the general rules, so your model will become too complex, captures noise. It is actually overfitting. Whereas hallucination is when your actual AI ML model generates output that is plausible sounding. Plausible sounding means, suppose it animal tiger can fly. It's possible, technically possible, it's sounding, but factually it is incorrect, right? So this kind of thing, if you train, so this is called hallucination, which is factually incorrect or not grounded in data. So this is an effect, is obviously it can mislead users, reduce trust, and produce unreliable results. So in actual LLM, and this can be tested in the exam also, obviously we should choose for the balance. What is the balance? You should have low bias and low variance. That is the good generalization, and it is applicable to any LLM in the market. Now come to what is overfitting and underfitting. So all these things, whatever we learned, bias, variance, learning, performance, model time, these all aspects are needed for overfitting and underfitting. The easiest thing to understand, overfitting means your model is able to perform very well till your training environment or with your training data set, but as soon as it moves to production with an unknown data, it is not able to perform. That means it has low bias but the high variance. This is called overfitting. And underfitting is it is your data is your training data set, it is not able to perform with your training data set, as well as in the production it's a unknown data set. So that is called underfitting, where it is high variance, sorry, high bias and low variance. So remember, whenever it is low bias means error from simplifying assumption in the model, and variance means for too much sensitivity to training data. So whenever you have low bias and high variance, that means overfitting. If you have underfitting, means high bias, low variance. For overfitting, learns training data too well, including noise. So that I was saying that in your training data set or in your staging environment, it is able to perform very well, but it fails in the production. And in underfitting, fails to learn enough from training data. It can happen in all the environments. Performance of overfitting good on training, poor on test. So no generalization. Underfitting poor on both training and test data set. Model type, overfitting it's too complex, underfitting it's too simple. So these are the general concepts I wanted to clear before going into a deep dive in SageMakers. So now there is another concept which I didn't clear in other videos. These are neural network types. So we have GAN, GAN, RNN, CNN. These are very complex topic, but there are one or two questions maximum you can get in the exam. So if you understand this slide properly, you will be able to answer those questions very easily. So what is GAN? GAN means generative adversarial networks. Generative adversarial networks. So try to understand or remember generative, that word. So that is in GAN. So it is actually compete between two networks, generator versus discriminator. So mainly GAN is used to create new or realistic data. Common use case can be for any kind of image generation, which is very in today's social media used to see those kind of from one of the popular faces, it is trying to generate another kind of face, or many kind of art can be generated using GAN. This is a neural network type. Or there can be style transformer or synthetic data, medical scans, MRI or X-ray kind of scan, gaming characters. These are the very common use cases for GANs. So just to understand in an intuitive way that whenever artist tries to fool the critic with fake but realistic creations, we can use GAN. So just remember generative adversarial network. So this is the GAN. RNN is recurrent neural network, means process subsequential data by remembering past inputs. Means it is, with RNN, we are not trying to generate any new data. We are trying to process the sequential data, what has been done in my past. So most common example is stocks. The stock was performing this in a particular way this month, last month. So how it will do in the next month. So this kind of time series forecasting, it can be on weather, sales, stocks, or it can be on the speech recognition also, audio or versus text. So based on the past inputs, it can process a sequential data that is called recurrent neural network, RNN. CNN is just the opposite. It's the convolutional neural network. If you see GAN, which is generating the images, here it can generating the images. What I just meant, generating the realistic or generate the new data. So in CNN, it detects the patterns in grid-like data like images or pixels. Here, it cannot generate the thing. It cannot generate the image. It is actually used for classifying, suppose image classification, medical imaging also. It can find out that from that X-ray, what is the actual problem. In a photo or video, try to find the object. Suppose in an image, where is the ant is present, that specific animal where is present, it can find it using CNN. So CNN is the pattern detector, RNN is the memory of the past, and GAN is artist versus critic. That is just the intuitive idea. I thought that will help you in the exam. So these are the things for neural network type. But if you want to go in more depth, I will give you a link. It is a very complex topic, and there are multiple things and multiple new discoveries are happening in this space. Now, these are the very two simple services in SageMaker I will tell you, and this will come up definitely in exam. One is SageMaker Ground Truth, and another is Augmented AI. So you might have heard, I believe you are already preparing for the exam, so you might have heard about this SageMaker Ground Truth and Augmented AI. So Ground Truth is, and both Ground Truth and Augmented AI, why I gave it in a table, because people gets confused that they used to say that uh, uh, in both Ground Truth and Augmented AI, human intervention is needed. And in exam also, you will see that the question will test you that you need to involve human intelligence is needed. So which AWS service you will use? So you might get confused. That's why I thought that table will be a better idea. So there is a slight difference. In augmented AI, human review to model prediction, it is actually mandatory. It's an inference stage. So I already explained what is inference. Whenever your actual testing starts after the training, right? So I will show you an image also that how it looks. So augmented AI is actually, adds a human review to model prediction, and it's a mandatory when model confidence score is low and rules trigger. And there is one main thing you need to remember: it happens after the model is predicted. After it's done the training and model is trying to make a prediction, then this human review of this inference stage is introduced. Whereas in SageMaker Ground Truth, human leveling to training data, that is also a stage, but it is optional. It is used for labeling the data before training. So there are multiple kind of training I already explained, right? Supervised learning, unsupervised learning, transfer learning, reinforcement learning. So labeling the data, that is actually supervised learning. So that kind of learning, if you want to do, there is a service in SageMaker Ground Truth, you can do human labeling. So whereas you are actually asking your team or people to do the training or labeling the data before training. So, and another thing is when it will be used, it is before the model is trained, you are using SageMaker Ground Truth. Whereas in augmented AI, after the model is trained. Now, there is another difference, just a small thing. Ground truth, customer manage the labeling process, set up labeling job, choose workforce, building workflows. It's just a BPM kind of thing, business process management kind of thing, where you can just think as a, you have created a ticket that will go to specific person will do the labeling, and after that you will build your workflow. That is ground truth. There is another kind of thing where is ground truth plus. Uh, Obviously ground truth plus, you was thinking that means obviously you will get something extra. Ground truth plus is that AWS is actually fully managed. Okay, you do not need to, you means the customer do not need to do anything here. AWS provide an expert workforce who will do the all the setup. You do not have in ground truth, you have the setup is needed where people from your team obviously need to be involved. They will configure the labeling apps, workflows, quality checks. Whereas with ground truth plus, all these things will be done by AWS himself. AWS themselves will do, and they will have an expert workforce. They will involve a team, but then, and obviously it is not a free. It's the there will be a cost overhead. Whereas if you use a ground truth, obviously you will have up to 40% of the based on the many data we found that 40% of the cost savings will be there. But still, if you want a fast no code managed labeling kind of thing, then ground truth plus, there are clients who use it. But just to tell you, there is something called ground truth plus. I just try to mention that also. So you understand what is ground truth and augmented AI. Just to give you a better understanding, just see this image where you have input data and there is AI service or custom ML model already is making prediction. Then you are involving augmented AI. That means it is not part of your training. It is actually happening after your trained, after your model is trained. And this is a mandatory thing. It is not an optional thing. Whereas SageMaker Ground Truth is optional. So augmented AI, here people are doing high confidence prediction, returned immediately to client application, low confidence prediction sent to human review. So this kind of review is happening, then it is going to client application. Whereas SageMaker Ground Truth, it is unlabeled image. People are doing this labeling and it is going through multiple iterations. Okay, so and this is happening before the training of your model. So this is the main difference between SageMaker Ground Truth and augmented AI. Both human are involved. Now you understand what is the minor difference between these two. Okay, now the interesting part of this video. Question 1. An AI practitioner is using an LLM to create content for marketing campaigns. The generated content sounds plausible and factual, but it is incorrect. I already discussed this. So what kind of behavior is this? This is called hallucination. Okay, going to answer, sorry, question 2. A company is building a solution to generate images for protective eyewear. The solution must have high accuracy and must minimize the risk of incorrect annotations. Which solution will meet these requirements? A. Human in the loop validation by using Amazon SageMaker Ground Truth Plus. Data augmentation by using an Amazon Bedrock knowledge base. Image recognition by using Amazon Recognition. Data summarization by using Amazon QuickSight Q. So if you see, it is asking the solution must have high accuracy and must minimize the risk of incorrect annotation. So they want to remove the incorrect risk of incorrect annotation. So in that case, human and augmented bedrock knowledge base will not help. Recognition is for image and video. It will not help. A quick sight is for dashboard. So only option we left it with option A, and obviously ground truth plus minimize the risk of error because it is involving AWS expert workforce. So and correct answer will be option A. Question 3. A company wants to develop an educational game where users answer questions such as a jar contains 6 red, 4 green, and 3 yellow marbles. What is the probability of choosing a green marble from the jar? It is an excellent question. Which solution meets this requirement with the least operational overhead? So A, use supervised learning to create a regression model that will predict probability. B, use reinforcement learning to train a model to return the probability. C, use code that will calculate probability by using simple rules and computations. D, deploy a fully managed ML service such as Amazon SageMaker Ground Truth Plus to label training data for probability questions. Think about this question. it is asking a jar contains 6 red, 4 green, 3 yellow marbles. What is the probability that of choosing green marble from the jar? So, do you not think that if we include supervised learning, reinforcement learning, ground truth, plus these all will be overwhelming, whereas question is asking least operational overhead, we could easily write this is a complete normal probability thing. If we include all these machine learning techniques, it will become more overwhelming solution. So easy thing is just we can use a code that will calculate probability by using simple rules and computation. We do not need to do that. So this type of questions can come in the exam. That's why I just put this question. Okay, so the answer is C. We do not need to use any machine learning techniques here. Question 4. A retail store wants to predict the demand for a specific product for the next few weeks by using Amazon SageMaker Deep AI forecasting algorithm. Which type of data will meet this requirement? Text data, image data, time series data, binary data. So obviously you can challenge me that you didn't mention what is deep AR. So that is I purposefully didn't mention and went into this kind of discussion. But yeah, now it's the question I can discuss. So deep AR is actually supervised learning algorithm for forecasting that is specifically designed to work with time series kind of data, which I was telling another time also for time series data for stock market prediction or future or it can be for simple kind of task where you need to data point collected or recorded at a regular time intervals. So it can be the daily sales also, hourly temperature, weekly demand, this kind of thing where text, images, or binary values are not suitable actually. You need to have an algorithm specifically for forecasting. So that's why if you see this in the exam, you can understand this DPR forecasting algorithm. This is if you go by the words also, you can understand forecasting. That means it's a time series data. So now I have mentioned what is DPR. You can just go through. You can pause the video and go through. So now question 5, a company wants to create an application by using Amazon Bedrock. The company has a limited budget and prefers flexibility without long-term commitment. Which Amazon Bedrock pricing model meets the requirement? On-demand, model customization, provision, throughput, spot instance. This I have actually explained you uh, in the beginning kind of video. So if you remember, then that is not, you do not need to have very good machine learning knowledge or cost optimization knowledge, this kind of thing only you can answer them. It's not like that. it is it is asking limited budget but flexibility without long term commitment, provision, throughput, or long term commitment normally it's for reserved instances, but they are not saying about the reserved instances. Spot instances, it can stop anytime. So, and model customization, obviously it is not a question, but provision, throughput, you could have think that is, but they didn't mention that long-term commitment or kind of thing. They want a flexibility. So on demand is the better fit because you will only pay what we will use, right? So based on the input or output tokens or generated content, it will be there. And obviously it fits because here we do not have with on demand we will not have any upfront investment, no long term lock in, ideal for experimentation or small budget kind of company, right? So just remember that whenever you have a requirement for startups or pilot projects or companies testing Gen AI without any predictable workloads, so on demand is the best answer. Okay, so thank you. Thank you for joining and see you in our next video. So we'll explain SageMaker other services. So see you in our next video. Thank you.